Hello everyone. This topic is about voltage regulator which is constructed using an op amp. There are two different types of voltage regulators. One is series voltage regulator, the other one is shunt voltage regulator. We have a very simple circuit that can be constructed as a voltage regulator, that is nothing but a Zener diode. Then what is the advantage of using a op amp as a voltage regulator? The main disadvantage of Zener diode that can be used as a voltage regulator is we cannot limit the value of the current. Once the diode is under reverse bias condition, the voltage is maintained as a fixed value, but at the same time the current exceeds its maximum limit. To avoid these problems, we use an op amp that can be used as a voltage regulator. In this diagram, we have a few important components which includes control circuit that can be constructed using a transistor. The other one is a comparator that can be constructed using an op amp. Sampling network, it is constructed using a potential divider, and finally followed by a load. The unregulated input is applied to a control circuit. The control circuit decides whether the signal, that is your unregulated input signal, has to be passed to the output section or not. This control circuit is operated with the help of a comparator. The comparator has two input signals. One is a reference voltage, other is a feedback signal taken from the output of sampling network. Once the output of comparator is positive or negative, that is capable of driving the control circuit either switches on or off. When it is on, the unregulated input signal is transferred to the output. When it is off, the circuit is being controlled. The circuit of series voltage regulator is as shown below. The resistor R3 followed by a Zener diode. Zener diode is serving the purpose of reference voltage as shown in the previous block diagram. The resistor R3 will be acting as a current limiting resistor, therefore protecting the transistor from getting damaged, at the same time limiting the value of the load current. The transistor is placed as a series component, so it is called as series pass transistor. The transistor gets activated once the output of the op amp remains positive. The output of the op amp produces initially a positive voltage because of the unregulated input signal which is developed as a reference voltage across the Zener diode. Therefore, once a transistor or the series pass transistor is in the on state, the input signal is transferred to the output. This creates load current across the resistance RL, which creates a voltage drop V0. The equivalent voltage of V0 is also being developed across the sampling network resistor R1 and R2. A small amount of voltage is being fed back to the inverting terminal of the op amp. Once the inverting terminal of the op amp reaches more voltage than the voltage applied to the non-inverting terminal, output of the op amp goes negative. This will drive the series pass transistor into off state. So the voltage which is applied to the non-inverting terminal is Vz. The voltage which is applied to the inverting terminal of the op amp will be equal to R2 by R1 plus R2 into V0. This should be an equivalent voltage which is applied to the non-inverting terminal based on the concept of virtual ground. So now in this case, the op amp will be acting as a comparator. So the output of comparator will be either plus VCC or minus VCC. This will drive the series pass transistor into on or the off state. Since the feedback signal is applied to the inverting terminal, we can clearly see that negative feedback is being used. In this way, the output value of the voltage is being regulated by limiting the value of input current to be passing towards the load resistance RL. The main advantage of this series pass transistor or series voltage regulator is it has very good efficiency. At the same time, for a very large input changes, a very small amount of low voltage change occurs, which is of the order of millivolts. Therefore, if efficiency is the main constraint, you can go for series voltage regulators. but the disadvantage is it does not have any short circuit protection. It has the advantage of negative feedback, but it does not have any short circuit protection. If this has to be included, we need to add some external circuitry. Thank you.